Okay, so let's go on with the applications of exponential and logarithmic functions. We're going to start up with the compound interest formula and a problem based on that. In this case, remember, every time you're solving exponential or logarithmic functions, the chances are you are solving for the exponent. So here's a situation when you start with $10,000 as initial investment, and at 7% compounded semi-annually. Okay, semi-annually, that's twice a year, so n is 2, and you want to make it to 1,000,000. We want to know how many years will it take. All right, so I suggest you write what you do know systematically in a kind of a table form, just like that, and then we are using the compound interest formula, so we're going to go ahead and plug numbers in, and then we come back and solve. So here it is. I plug numbers in, and then we are solving for t up here. Okay, that's what we are. The 2 is the semi-annually. So when we simplify, we divide both sides by 10,000, we're going to get this equation, and then we take the log of both sides, and this is the part where, remember, when you take the log of both sides, the 2t comes in front of the log, and now you have to solve for t. Divide everything by all the numbers or coefficients of t, coefficient of t, both sides, and then take out your calculator and find out what the value is. And it turns out it will take about 66 years. If I'm not mistaken, double check, but that's what you will get to make $1 million out of the $10,000 investment at 7% compounded semi-annually. All right, let's go to the next question. This time it's about light intensity. A scuba diver stands below the ocean surface. For every meter, the light intensity reduced by 2.5%, and we want to know the depth in which the light intensity will be 50%. I have set this up already. So what it is that you're using the basically the compound interest formula, but in a kind of a differentiated way. So you start with the final amount that you want is your 50% or 50. The initial amount is 100, so that's 100 right there. And then because this 2.5% is reduced, right? Reduced means going down. You start with 1, but you're subtracting the 0.25 out of that. And then d is that distance from the surface. And then you plug numbers in. You do the same thing as we did with the compound interest. And in this case, you take the log of both sides. And when you do the log of both sides, so here it is, and then d comes to the front, then you get log of 0.5 equal to d log of 0.975, then divide both sides by log of 0.975. When you do the math on that one, you're going to take out a calculator and punch that in, and then you'll get d around 27.4 meters deep. At that, where you get the light intensity, so where you get 50% light intensity. Okay, that's what you will get. Okay, sorry, I had to pull up the page. Here it is at d equal to 27.4 meters, and where it's 50% at 50% light intensity. Okay, very good. All right, let's go to the next question. So this is an example of the of a half-life. The Chernobyl power plant in 1986. You can actually look it up. This is a true story, unfortunately. The explosion there basically contaminated the area with the iodine 131, radioactive iodine 131, and the half-life of that is 8.1 days. All right, so that means it takes 8.1 days so that the amount of contamination, the amount of that drops to half of what it started with. The question is, how long will it take so that the level of radiation to reduce to 1% so that it's semi-safe to do whatever that they needed to do? And we want to compare that to the immediately after the accident. Okay, so here is basically the half-life formula that you actually used to using when we were dealing with the exponential section. So we want to get 1, that's the final amount. we started with 100. That's a half-life, 1/2. That's your value inside. The top t is the time that it takes to get to amount that is left, and 8.1 is the time of the half-life. All right, punch that in. Now all you have to do, there are two ways to do this. You can either take the log of both sides, or as I would do that, I would just divide both sides by 100, so you get 1/100 equals to 1/2 to the power of t divided by 8.1. Okay, so if you do it that way, it may be a little bit easier because you don't have to deal with negative. All right, now you take the log of both sides and then you go through it that way. So it would be t divided by 8.1 times the log of 1/2. Okay, and then in this case, all you have to do, you're solving for t, so that means you have to multiply both sides by 8.1 and then divide both sides by log of half. T equals, so when you do the mathematical gymnastics here, you are solving for t, you will get 54 days. Make sure that you are doing the multiplication right. So log of 1/100, that's basically -2, because that's 0.01. Okay, so that's 8.1 times times -2, and then divided by the log of half. You can use a calculator, and then you'll end up getting 54 days. All right, that's the answer to that one. It takes 54 days where the radiation level is used to 1% level immediately after the accident. So the next one is the earthquake and Richter scale. That's basically the measure of the strength of earthquake. That was developed by Charles Richter. It's a logarithmic scale. It's based on powers of tens. All right, and the idea is that when we say, for example, that a certain earthquake had 6.5 on a Richter scale, the idea is that it's 10 to the power of 6.5. Okay, and we use that in reference to compare it to the other. For example, if we have one that is magnitude of 6.5 on a Richter scale and comparison to magnitude of 9.6 on a Richter scale, that's how we write it. But in terms of the comparison, the idea is that for every 1 unit magnitude increase on a Richter scale, we have 10-fold increases in intensity. That means 10 times more powerful. So for example, the magnitude of 5 comparing to magnitude of 4, that is 10 times more powerful. So the way I can write is that if I write 10 to the power of 5 and versus 10 to the power of 4, I want to find out the difference between the two. It becomes a ratio that would be 10 to the power of 1. That means that is the 10 times, actually let me put it times, more powerful. Okay, simple as that. So what is, if you want to compare these two guys here, okay, two earthquakes, one 9.6, the other one 6.5, you want to know how much more powerful 9.6 was in comparison to 10 to 6.5. So that would be, so here is the 9.6. You divide that by 10.65. The difference between the two is 3.1. So you take out your calculator, you punch that in. Let's do it again. 10 to the power of 3.1. So notice that it will be 1,259 approximately times more powerful. All right, so that's basically it.